Do you yearn for space travel? Do you have $450,000 to purchase a ticket with the aerospace company Virgin Galactic? If not, don't fret. You can still travel through space vicariously via the James Webb Space Telescope. It's not just a space telescope, it's an infrared space observatory. The James Webb Space Telescope, or JWST, launched on Christmas Day, December 25th of 2021, and as it probes the cosmos, it maps outer space glancing into regions of space that have previously been virtually undetectable. Instead of strapping on your spacesuit, simply kick back with some snacks in hand, while space infinity blasts you to the strange new discoveries, courtesy of the James Webb Space Telescope. Here's everything you need to know about the construction and deployment of the James Webb Space Telescope. The $10 billion James Webb Space Telescope is NASA's largest and most powerful space science telescope. As this great observatory with huge space instruments akin to the Hubble Space Telescope, its main objective is to peer deep into the cosmos, to uncover the history of the universe. That means NASA is virtually trying to peer back to the beginning of the universe from the Big Bang. While accomplishing that main objective, it will be able to view planets that could potentially host alien life forms. To accomplish these feats, the JWST comes equipped with 4 science instruments that will enable observations in visible, near-infrared, and mid-infrared, registering 0.6 to 28.5 micrometer wavelengths. It blasted off into space from European Space Agency, or ESA's, launch site at Corral in French Guiana on board an ARIANESPACE Ariane 5 rocket. Due to its massive size, the JWST had to be folded inside the Ariane 5 rocket. It's more than 3 floors tall, as wide as a tennis court, and it's one of the most difficult space scientific projects ever attempted. Then, while in space, the telescope must accomplish the challenging mechanical feat of constructing itself. NASA has warned that this maneuver is extremely risky, with more than 300 technical issues that could jeopardize the mission's success. It took 30 days for the JWST to travel nearly 1 million miles, or about 1.5 million kilometers, to its permanent home at a Lagrange point. This is an area with a gravitationally stable location in space. The telescope arrived at L2, the second Sun-Earth Lagrange point, at the end of January of this year. L2 is a spot in space near Earth that lies opposite from the Sun. This orbit will allow the telescope to stay in line with Earth as it orbits the Sun. It has been a popular spot for several other space telescopes, including the Herschel Space Telescope and the Planck Space Observatory. Lagrange points are also used by spacecraft to reduce fuel consumption. Before the JWST is operational, a sequence of tests, including sun shield deployment, telescope deployment and alignment, instrument turn-on, and calibration, must be completed before the telescope may be used. The calibrations and modifications will have to be done remotely because, of course, the JWST is far beyond reach. To construct the James Webb Space Telescope, an impressive international collaboration commenced consisting of NASA, the European Space Agency known as ESA, and the Canadian Space Agency. This collaboration also embodied over 300 universities, organizations, and companies across 29 U.S. states and 14 countries. And although all of these organizations built the JWST with a realistic duration of 5 years, the goal is to keep it operational for more than 10 years. The JWST has 4 main objectives. First of all, the James Webb Space Telescope will attempt to detect the very first light of the universe. From there, the objective is to map the galaxies of the universe. The third and fourth intention is to gather data on the birth of stars and protoplanetary systems. A protoplanet, in astronomical theory, is a hypothetical eddy or a circular movement in a whirling cloud of gas or dust that becomes a planet by condensation during formation of a solar system. According to NASA, this information could show humankind the origins of life, and the Space Telescope Science Institute claims that the first images of the JWST will begin to appear 6 months after its launch. But for now, let's delve deeper into the 4 specific goals of the JWST. This stage targets the early stages of the universe after the Big Bang occurred, which started the universe. In the first stages after the Big Bang, the universe was a sea of particles, filled with electrons, protons, and neutrons, and light was not visible until the universe cooled enough for these particles to begin combining. This study by the JWST will shed light, pun intended, on the formations of the first stars. This brings us to reionization, or the era known as the Epoch of Reionization. The Epoch of Reionization, EOR, refers to the period in the history of the universe during which the predominantly neutral intergalactic medium was ionized by the emergence of the first luminous sources. These sources may have been stars, galaxies, quasars, or some combination of them all. This was the time when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from the first stars. To gain clues to the puzzle of how the universe evolved, galaxy gazing with the JWST will show how matter is organized on gigantic scales. The spiral and elliptical galaxies we see today actually evolved from different shapes over billions of years, and one of JWST's goals is to look back at the earliest galaxies to get a better understanding of that celestial evolution. Particularly, the JWST will help scientists get a thorough grasp on how the various galaxies formed and the current ways that galaxies form and assemble today. Pillars of Creation is the name of a photograph that was taken by the JWST's predecessor, the Hubble Space Telescope. The photo shows of elephant trunk-looking interstellar gas and dust pillars in the Eagle Nebula in the Serpens constellation. These structures are approximately 6,500 to 7,000 light-years from Earth. Inside the Eagle Nebula's Pillars of Creation are some of the most famous birthplaces for stars. Stars come to be in the clouds of gas, and as the stars grow, the radiation pressure they exert blows away the cocooning gas. However, it was nearly impossible to see inside the gas. But that is not the case for the JWST's infrared eyes that are able to look at sources of heat, including stars that are being born in these cocoons of dust and gas. The JWST's spectroscopes will be able to see inside those early galaxies' chemical kitchens, seeing what was cooking within individual stars and what they fertilized the universe with as they burst in tremendous supernovas. With the help of many telescopes, especially the Kepler Space Telescope, which was launched in 2009, a vast number of exoplanets have been discovered. JWST's powerful sensors will be able to peer at these planets in more depth, including actually being able to snap and send images of their atmospheres. Understanding the atmospheres and the formation conditions for planets could help scientists better predict if certain planets are habitable. Not only is the James Webb Space Telescope set to map the universe, it's going to map the atmosphere of exoplanets. Keep in mind that exoplanets is the term given to extrasolar planets or any planetary body that lies outside our solar system. Extrasolar planets were first discovered 30 years ago in the early 1990s. Since then, more than 4,000 have been discovered and about 6,000 await further confirmation. One of the most popular exoplanets is Proxima Centauri b, which is about 4.2 light-years away from Earth, or about 265,000 times the distance between the Earth and the Sun. It orbits in a triple-star system called Alpha Centauri, so the JWST will surely be sending never-before-seen images of Proxima Centauri b, its sibling exoplanets, and of course its red dwarf star. Similarly to Jupiter's Great Red Spot, Saturn's rings, or the ice caps of Mars, some celestial bodies just can't be seen with the naked eye. But due to the advancements of the JWST, a brand new map of our closest solar neighbors are soon to be revealed. For an extra boost of productivity, the Hubble, which has been operating for over 31 years, collecting groundbreaking science observations, is expected to work with its successor, the JWST. NASA expects the two observatories to work together well into this decade, expanding our knowledge of the cosmos even further. Fortunately for astronomers, the Hubble Space Telescope is still functional, even though it suffered some wear and tear throughout the years. For more cosmic revelations, be sure to keep in contact with Space Infinity. All you have to do is tap that like button and subscribe. For more journeys through space, watch these other videos from Space Infinity.